session, we wanted to finish this workflow. So this is the original workflow. We had this robot. It was supposed to grab something and then move up and then go to the target and drop it over there. So this was the plan. And if you remember in the previous class, we have done some part of this, not the whole thing. Let me just bring it back. So we started from here and we went here, grabbed the object and came up all the way to here. And you're supposed to help with the rest. Who wants to get volunteer and do it for us?
Do you mean screen share?
Yeah.
Can you see?
Yes, we can see it now.
Okay. Wait. Oh, okay.
Yeah, you're in the correct. So right now you're in Home tab. You're in the Path and Targets, and you can see the work object, and under the work object, you can see all the peak place. Oh, so you called it drop. That's fine. Okay, good. Now, can you explain like which points that you selected there? Can you zoom in on the targets?
Yeah.
So my suggestion for zooming on a target is to actually double click on those targets in the menu on the left. Yeah, so it's going to...
Oh, okay.
Yes.
I want to rotate a little bit.
Just give me a second. I need to bring my iPad so I can put comments. Go ahead.
Oh, okay. So this is like the starting point, the start, and then it goes to the first save position, and then that's when it starts to slow down, and then it and then it kind of return to the save position, and then it kind of move horizontally to the second save position slowly,
Okay.
and then where's the drop? Okay, and then it goes down to the like drop position, which has the same Z value.
Okay.
Yeah.
Seems pretty legit. So let me just join to the meeting from my iPad. Make sure that. Okay, good. So I think the progress is pretty interesting. Like it's actually correct. But let me just draw the path for you. So you first start from here. You go down. And this is the save point. Am I correct?
Yes.
And then it goes even further down for peak place. Oh, it's here. Now I see it. And then you get back to this save point, which is your third point. And then you move here, which is the fourth, 5, and I think this is 6. I think the overall procedure is pretty fine. It's exactly what we were looking for. The only thing that's missing here is that it's usually a good idea to jump from that save point to this could be somewhere here at the middle, okay? And then you could go down, come back, go here, then go here, then go here. The reason is the fact that in this area, you didn't move up enough, okay? You usually do not move up enough. So it means that if you have a couple of these blocks next to each other, and then you first grab the first one and you don't go high enough, when you try to get to the next one, you may actually collide with them. So my suggestion is to actually move this point into somewhere here at the center, and then in order to make sure that you're fine with the rest, then from here you go further. It is also going to be a little bit problematic if you don't go high enough when you are trying to stack these boxes on top of each other. So if you want to put like, I don't know, 4 or 5 of these things on top of each other, if you don't get back to some point here and then from here start to put down, you will have some problems. But overall speaking, it's pretty nice. It's pretty close to what we are looking for. But you just define the targets, okay? We need to make a path to make the robot move along these targets. Okay, so first I think what you should do is to just move these two targets slightly higher. So I think it would be a good idea to push them a lot, like 20 millimeters higher, or maybe like 50 millimeters higher. Let me correct number. And can you do that?
Oh, yeah.
Okay. So yeah, pick safe, modify target, exactly. Now, here we can do something. Okay, so you have two options. You can do it with world, which means that it's going to use the world coordination system to move these targets up. You can also use the local ones. At this moment, it doesn't make that much of difference. The only problem is that when you're using the world coordination system, Z is facing up. But when you're using this like local coordination system, as you can see, the blue is facing down. So you should be careful about the number that you're using. But just for the sake of having some sort of tradition, let's use local, because then in rotation, it's also really important. And you see that the positive Z is facing down. So you want to move these targets up. No, so yeah, you should move it in negative direction for something like 50 millimeters. I think 50 would be more viable.
50?
Yes, please. Okay. So you see that this red circle shows the new target for you? So it used to be somewhere here. Now it's here. Okay, good. So you applied that one. Seems better. Also do the same thing. To be honest, you can actually select multiple points and then change this value for all of them.
Oh,
so
I
it would be easier. Okay, apply that one. Okay, good. My suggestion is to actually move this target also slightly in this direction, maybe for like 50 millimeters into its right. Okay, exactly. So I want to move. You want to move it along this red axis. So you change the red color. So and it's in positive direction. So I think maybe 100 millimeter it would be fine. Just change the number and see where does it go. Yeah, that might be good. Yeah, good. So you have this target here. Now you can actually design the workflow. So right now your robot goes from here to here, then goes here, then comes up here, which is, I think, in this part of your code. Okay. You want to make sure that your robot actually turns back to this point. And you just need to drag and drop it, yes. But you see that the order is wrong right now. So I think right now the order is...
Yeah,
just drag and drop it. Yeah, just drag it to the correct place. Yes. Now you're in correct mode. Okay, so right now you have a procedure that goes from here, here, goes here, and comes back here. So let's keep these two separate. Okay, we want to have one peak, and we want to have a place. And this is going to be sometimes helpful, sometimes it's not going to be helpful. I just want to clarify that these two are different. So right now you have a path that's called path 20. You can actually rename this one into something like peak process. Please change it to peak process. I think if you right click on that and hit rename, yes. So change the name, and always remember, never put a space bar between these things, and always keep an underscore or keep them like a camel casing or something like that to make sure that there's no space between them, because later on today we're going to discuss this one. Okay, so you have one procedure, one path here. Later on we're going to call it procedure for picking up. Now let's make a new path and use that one in order to apply the place or dropping process. I think if you just go on path and process and right click on it, like a little bit further, yeah, let's see. No, I think you should right click somewhere here.
Copy?
No. In the copy, it works, but not the case. Like right click here.
Oh.
Yes. And I think create a path. Yes. Okay. Name this one as place process. Okay. So this is the way we clarify these procedures and keep them away from each other. So you can actually, so I think right now you have this move and this move here. You can actually drag and drop them from here to this new process and then we can actually clarify everything.
Okay.
Just select both of them, holding control, yeah, and drop them into the other one. Yeah. So you have two paths, one that does the pick and one that does the place. But you still need to clean it up, add extra points. So make sure that it starts from here, goes here, comes back here, and goes up here. So it should have actually 1, 2, 3, 4, 5 commands.
Okay.
Don't move from the previous one, because if you move it from the previous one, then you're going to lose it. So Control Z, so you get back. Now, if you want to make new ones, you should pick from here and drop them.
Oh, I see.
Yes.
Oh.
Okay. Good. Oh, it puts it at the end. And it doesn't put something at the beginning. That's also a catch. So you should do something like that one. Okay. So let's see. You start from here. You go to move safe. You go to drop. You need to move safe again.
Oh.
Good. So you have all the actions, like the motion actions, and it seems fine. But do you remember from the last time we were talking about different move J's and move L? So basically, remember for this part, you could go with move J, with V, I don't know, maybe 200, with Z of 0 or 10 or whatever. And for the rest, we would go for move L, V like 10, or maybe like 50, and Z 0. And for this one, L, V 10, even fine. So you need to also edit these parts. Okay, so you can basically, right now, you have only one move J, which is not the correct move J. So for the first one, you can have move J for the first and last. So basically, you can hold control and edit these two together. Okay, that's fine. Go ahead.
Oh.
Right click and edit instruction.
Okay.
Yeah, it's there right under your mouse. Okay, great. Now, yes, it should be move J, and speed is too fast. Let's make it like 200. Like 200 is not too fast. And the Z value should be something around 10 or something in that capacity. The reason is that when you're moving into this position, you're away from your object targets and you're away from anything essentially important. So you can just stay away from it. And it doesn't matter if you move fast. For the second one, so for the 3 next targets, I think you can select them all together.
How do you get into that upper menu again?
So you right click on the target and then modify instruction.
Okay.
We usually use this one when we want to convert something from move L to move J and back, because then it opens this, advanced menu. If you just want to change the Z value or something like that, you just modify the instruction. Can you right click again? I think I missed the title. Yes, modify instruction. So there are two options: edit instruction and modify instruction.
Oh.
Edit instruction gives you the option to change move J and move L. But modify instruction gives you this, options for a speed, zone, and tool. So you can
change Z and L, right?
What was that?
Can we change Z and L instead of modify instruction?
No, you should actually go to edit instruction and then change the type of motion.
Okay.
So it's up there. It's already open. You can actually change it into move L. Okay, so it's speed. Oh, I cleaned everything. My bad. So let's say, let's put Z equals to 10, V equal to 10, and Z equal to 0. Okay, now for move L drop, the same thing, but instead of Z equal 0, let's see Z equal to 5. Yep, good. The same applies to this one, B10. And Z0. Okay. Did you hit apply in the last one?
I don't think.
Okay, don't forget. That's really important. Okay. 10? Yes. Awesome.
Okay.
Just
Right.
to clarify, what you're doing here is just making sure that like once the box is about to be placed, that it
Uh-huh.
moves slower and is more accurate.
Exactly. So whenever you are a little bit confused about this workflow and why we do this and why do we set these speeds and zone values, grab something a little bit, dangerous in your hand, like it's a glass of lemon water, and then try to move it around with this speed that you see here. You see that if you want to grab this glass of water that includes lemon juice, which means that if it drips on my keyboard is going to be definitely dead. Think about it how you grab it. You move around quickly, then you move slowly, you hold it. You wait for a second to make sure that you're holding it, and then you move it around, okay? When you come back to put it on the table, you may actually move a little bit fast, but then you move it slow. Then you slowly go down, wait for a second, you release your fingers, and then you go away. One thing you never want to do is to actually, before leaving it, before you actually completely remove it from your hand, you don't want to move, retract your hand, because if I still keep this one and try to move my hand, it's going to fall over. If you forget to wait for a second or so and then release it before hitting the table, it's going to fall down. So whenever you're trying to get the logic of doing something with a robot, it's a good idea to do the same thing with your hands and see how's it working. So I think right now we are fine with this workflow, with the accuracy, with the Z values. I just want to reiterate the fact that the difference between Z0 and Z equal to fine is pretty subtle. So if you remember, Z means that if this is your target, Z means that your robot is going to get here and then turn around and goes away, okay? Even though you want to touch this target, this Z value is going to help the robot to prevent from a full stop at that target. So the robot goes here and then turns around without touching that target. And the distance between the real path of the robot and the target is called the Z value, the zone in which the robot assumes that if I touch that zone, I'm going to assume that I have touched the target. It's going to help us to have a smoother action. Z0 means that we are going to have a really, really, really small gap between the target and the curvature of robot motion, which is pretty close to zero, but it's not zero. But fine means that we are getting as much as possible closer to the target, and we are going to make it dead stop at that point. So in Z0, the robot moves like this, almost touches the target, but it smoothly goes away. In fine, it means that the robot goes there, stops there, touch that, and goes away. So it seems like not a big deal, like stopping at the target, it seems fine. But once you start working, for example, with hot wire cutter, or if you start painting with the robot, or anything that's time sensitive, that quick, small gap, the hiccup, is going to be essentially ruining everything. Also, it seems that it's going to have some effects on the longevity of using these robots. Like every time that the robot makes a dead stop at the end of a target, it's going to put extra pressure on all pieces of the mechanical system. And imagine that in the path that we are designing for this class, usually we have like thousands of those stops, and the robot is essentially going to move like that, which is crazy. But when you have Z1 or Z5 or something, the robot is going to make a smooth move. Okay, so I think we are good in this track. We understand what's going on here.
For the save, can we use like move J as long as we set like Z to be 0 or 5?
So you mean about this one?
Yeah.
Okay, so let's see. So that one is responsible for moving from this point to this point. Okay. And also previously it's responsible for getting here to here. No, actually from here to here. I strongly suggest that to keep this one also as a move L. The reason is that, for example, imagine that you are trying to put something inside something else. So let me just think about what do I have around here that I can demo this. So this is a lens hood. This is a lens. So imagine that this is the place that you want to put this lens inside of it. So the target here, and this is the safe place, okay? and I know that I put the foot upside down. But imagine that I go down here and put this thing here, okay? This is definitely move L because I don't want to make a motion like this, like anything other than linear. So I move linearly inside, and then I go all the way in. Now I want to release this one and come out. If I use move J for retracting from the final target, my hand is going to make a motion like this, like, which means that I may actually have a collision with the body of this like food. But if I make the exact motion that I made previously, like another move L and come up, then it means that the way I got in, I'm just going to exactly pull back and come back from the same direction. And it's a kind of safe action. So always like think about it in this way and try to imagine the whole workflow in your mind before setting these motions. And once you get familiar with this concept, you're going to repeat it again and again and again, and you get more comfortable and more experience in this workflow, and it's not going to be a big deal for you from the next time. Okay, so it seems that we are good.
Just to
go ahead.
Clarify one more time. So essentially, like the Z value or the sorts
The zone value. Yeah.
Is basically sort of defining how close you get to a particular point, and
Exactly.
then like the move L, move J is the sort of vector that gets to the point. If I'm correct.
Okay, so I think you're completely correct about the Z value. So the Z value just defines that distance. So basically, it says that how far, how close the robot gets to the target. Okay, that's the correct one. On the other hand, the move J and move L are two different ways to move between two targets. Okay, move L says that the robot is going to follow a strict linear path between two targets. This is the way it works. So it means that when you're doing a move L, the robot tries to make sure that the TCP and the tool are exactly moving linearly between two targets. And it is sometimes super helpful when you are doing something accurate. But if you want to make a big motion from one part of the space to another one, or if you want to quickly move between 2 points without being concerned about the type of motion that you're doing, we are using move J. Move J means that the robot is going to find the most efficient way to reconfigure its joint to get from point A to point B. That means the TCP, or the end of the robot, the end of the tool, for example, the head of this pen, may not move along a linear path. It may actually make a move like this to get from here to here. The whole body of the robot is going to move around, but the TCP of the robot may make this motion, and it is really important. For example, imagine that you have a scenario in which this is the environment, and you have a robot here. Okay, this is the robot, and you have a target here, okay? And then you have another target here on the other side of the robot. If I use move L, this robot will try its best to move linearly from here to here. And when I say the robot tries to move, I mean that the robot tries to move the TCP, or its end of tool, linearly between these 2 points. If one point is on one side of the robot, and the other point is the other side of the robot tries to move along itself and collide with itself. So it means that it's not possible. The robot is getting into a configuration error, self-collision error, and it's not going to do the job. On the other hand, if you just use a move J command, this robot actually makes a motion like this, and gets from point A to point B without any problem. You're going to see it a lot. Like in the lab on Thursday when we go there, I will do the same thing with move L and move J, and you will realize that how smoother, faster, and more controllable is move J. Move L is really helpful when you want to make sure 100% you have control over what's happening. And move J is good when you don't want to get considered with all these like extra actions. The robot is going to take care of most of it. When we get into like serious simulation, we will actually follow the tracing the robot, and you will see how is it working. Okay, is that clear? Good, 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 good. So now hopefully my file is ready in the background. I have everything here. Let's see. Okay, so thank you very much for sharing your screen. I think it was a productive session. I learned also I'm going to stop sharing and then sharing my own screen with the Robot Studio. Okay, so this is almost the file that we used to have. So I'm going to quickly reproduce whatever we had in the past. Okay, these are the targets. Good. Okay, so I'm going to move my robot back here. Here. Good. Okay, so everything is fine on this side. Let's get here. And I'm going to quickly reproduce that workflow because I think it's worth having a further look. Okay, good. This target is here. We want to make those extra targets around the corner. So what I'm going to do is very quickly reproduce these two targets. So I just copy paste them. Let's see if it's copy paste them. I think it's not going to paste them there. Okay, so I'm going to make two targets in this vicinity, or maybe I can make a new work object. It doesn't make that much of a difference. Okay, so teach the target at this point. See the robot here. Good. Okay. Okay, good. So this is the target peak point, and this is the save point. I'm going to just drag this robot and see if I can do this part. Okay, turn off this part. Okay, this is the peak place. I'm going to place them here. So I will teach one target and teach target, and I will call this one place. And then I move the target, the robot slightly higher, like somewhere here. And then I'm going to call this one, yeah, place safe. Okay, so I have all the four targets. Let's delete the ones that I don't want. Yep, good. So I have, let's see what's going on here. So this is the start point. This is the start point. This is the save point. Okay, I just need to change these names. So it's going to be pick safe. Okay, pick point, place. Just trying to follow the same convention of naming. So everything is going to be in the correct place. So starting point, pick safe, pick point, starting point, place safe, and place point. Okay, and now I can actually make that path. I think I already have the peak path, and I added some extra actions here. So I'm not going to touch that one. I'm going to make a new path using these three. Make a new path. A new path. Let's call it the peak process. And then I will have this start, peak safe, peak point, and make a new process. And let's call this one place process. Good. So we have these. We should first start with the place point. Where's the start? Did I miss something? Yeah. So I first move to start point. Okay, and then I will go to pick safe, pick one. And did I make a mistake about the naming? Pick point, place point, place safe, start point. Okay. Oh, this should not be here. Safe point, and then I need to make another peak safe. And as we know, this one should be move J. Edit instruction. This should be move J. Okay. So I'm just going to keep the old speeds and other stuff the same, just for the sake of speed. Apply. Okay. Here. Place, start. Okay. Okay. Save. Good. So we have start. Okay, good. And maybe we should also at the end get back to the starting point. Good. We need to have another one also here. Yep. Oh, I made a mistake about that one. Sorry. So whenever I'm trying to copy paste one of these passes, it says, do you want to actually make a new target for it? And I said, no, thank you. I'm fine. Okay. And I just need to have this one also. Nope. Okay. Good. So we have the whole workflow. We start from here, we go here, pick up the workflow. So in order to make sure that everything is working, I'm going to move along this path and see what's going on. Oh, it actually does the pickup procedure for us. Seems cool. Okay, it's too much of simulation here, so I'm going to stop it. I think I added too much. Let's see, collisions and other stuff. Let me remove this part. I think we're not going to cover this one for today. Okay, we're good. Okay, good. So we have all those paths. We have this like pick process and we have this place process. And everything seems cool and fine. The Z values are actually not accurate. So let me just make sure that I have the correct Z value. Let's go for Z0. So it seems fine right now. Everything seems fine. But we wanted to add some extra stuff. So just to make everything clear, I'm just going to hide this robot, which is not helping us today. So cleaner space here. Also, I'm going to clean up its, where's that one? Okay, here. So it's not going to interrupt with our workflow. I can actually delete these two targets here because we're not using them. And it just makes the environment slightly cluttered. So good. So we have this robot with its targets around. And right now, it seems that everything is fine. It's just like moves from this point to this point, goes down, moves back, and everything seems pretty fine. But actually it is not. We need to somehow consider some extra actions. And those extra actions are something that we, in our practice, always use, but we might not be aware of them. For example, when we want to grab something, we actually get to that object, and then we stop for a second, get into complete stop, then grab the object, and then wait for a fraction of a second to make sure that we grab that object, and then we move away. So in the process of doing this robotic workflows, we are doing this a lot. We always make sure that, for example, the robot gets to that target, and then wait for an amount of time. And then we do some extra things in the background. For example, open or close the gripper, and then continue moving around. So while all these commands that we made here are basically motion actions, we also may need to have some instruction for the robot to do something in between. And those are actually getting very, very important when you're doing something seriously accurate and delicate. And I'm going to teach you how to do that. The first thing that we are going to think about is a command called, you can guess, it's called waiting. So waiting is basically a really, really simple command. You just ask the robot to wait for something or wait for amount of time. And the robot is going to either get to that point and wait right after that, or it's going to make sure that it's going to wait while moving around before doing something. So I'm going to start with the easier one. So as I mentioned, like when you get into a target and you are there and you want to start grabbing it, you would stop for a fraction of a second. And this is the part that we are going to do this. For example, we start from this position, then we go to this safe place, and then we go down to grab this object. This is the moment in which we need to wait for a second or so. So here I can right click, and instead of adding a move instruction, I can say that I want to have an action instruction. And whenever I click on that one, again, it's here. Right click on any place that you want and on the path, and then insert action instruction. Here, it asks you which robot you want to do this with. So by default, it's going to select a robot that you have already selected, like this. Right now, it's working with this 6640, which is called 66 offline, blah, 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 blah. And then it asks you which path you want to work with. So basically, if you have right-clicked here, it's going to automatically populate this correct path for you. But then it's asking you, like, what exactly you want to do. And in many cases, we are just going to play with two sets of commands here. We are going to either play with these set DOs, which is set digital output, which is a topic I'm going to cover in a few minutes. But more than often, we are working with this wait time, which basically asks the robot to wait for a fraction of a second. Okay, so it has two options. One of them is like in position, and the other one is time. We usually provide amount of time that we want to wait in seconds. For example, if I want to wait for 1 second, I just hit 1. It's different from other languages that are using milliseconds. Like I think Python or processing uses milliseconds. So instead of 1, you should write 1,000. Don't do it here if you don't want to wait for 20 minutes for any waiting things. And I suggest for now, hit in position as enabled. It is not intuitive right now. What does this in position do? But basically, it is if there's a motion command, like for example, move L, and the robot is supposed to get to this point, wait time with having the in position enabled means that it waits for the robot to get exactly to this point, and then it starts counting like Mississippi 1, Mississippi 2, Mississippi 3. But if you disable the in position, it actually starts counting from somewhere here before getting to the target. And it is not a good idea because, for example, imagine that you want to close the gripper once you get to this glass. And if you don't enable this in position, it means that the robot is going to start closing its fingers before getting to the glass. But if you have that in position on, it means that the robot gets exactly the glass, then tries to close its fingers. So to be in safe side, let's keep these two commands here. And when you are done with these two settings, you just hit create. And it is going to make this lightning sign here, and it's going to add this command at the middle. Now, if I hit this move along the path, you can see that, oh, okay. So the robot starts from that top there. It gets to this target. I'm not sure if it's going to simulate that here. Yeah, it actually waits for a second and then comes back, which is something that pretty meaningful. Like you go there, you slowly grab the object, and then you come back. Okay, it seems cool. It's exactly what we were looking for. And then the same logic applies to the placing workflow. When you are done with placing, when you are just putting the object down, you want to wait for a second and then open your fingers and then move back. I may actually add something here at the middle, but let's go and do this with the placing. So I'm going to do the same thing with placing. So I can either right click here and insert action, or I can use the same command, same menu that I had previously. I prefer to every time go to this menu and hit insert action because it immediately automatically updates the place I want to insert this command. So again, I'm going to add a wait time. I make sure that it's enabled, and I will make sure that it is set to, for example, 1 second. And I will hit create. And these wait commands are going to be there. So it's pretty straightforward, pretty simple, and it works the way it should. But you've seen something different in this video that I had here. Like, let me just bring it up here. So you could see that in this case, this gripper actually closes and opens at the moment I'm doing it. Okay, and this is something I'm going to explain for you, which is going to be helpful. But to be honest, I'm not sure if you are going to cover this like actual action of grabbing for today, but let's see. So what we are going to do is to actually add a command that help us make this gripper close, or on the other side gets open. So this is something that we do using something called digital output on the robot. So basically, digital outputs are electric signals that we can send from the robot controller to the terminals on the body of the robot. So basically, here is our robot. There's actually, if you look at the picture of the our lab, there are some controllers sitting in this corner that are not visible in this simulation, but these controllers are the essential part of the robot that help us to communicate with the robot and control it. So whenever we set one of these DOs on the robot, that controller sends a signal, electric signal, to some device outside of the robot, and that device can actually add maybe air pressure, can send electric signals or whatever. In this case, we want to send a signal to this gripper and say, please open or please close. No, open or close. And when we get to the lab, I will explain in more detail, slightly differently from what I'm doing here, because right now I'm just trying to make it easier to understand. But these are basically pneumatic grippers. They are made by a really famous company that I don't know how to pronounce its name. It seems it's named Schenk. It's a German name as far as I understood. But basically, they receive air pressure on one side of this mechanical system here. And when they receive that air pressure from that side, it's going to slide open two tabs. And then when you apply air pressure to the other side of it and stop the air pressure from this one, it's going to close those tabs. And they are always forcefully doing it. So for example, if you try to hold it by hand and open it, it's going to actually push your hands. Or if you try to stop it from closing, it's going to add a lot of pressure. And the safety alert, never try to stop the things with hand. Never try to stop them with anything, because they are industrial grade tools and they're really powerful. Anyway, for now, I'm going just to assume that they are simple tools that open or close by a signal. Okay, and we will just send that signal to this tool, and it's going to close, and then we send it back or reverse that signal, and it's going to close it. It is getting way funnier and way cooler when you're doing it on the real robot with all the sound effects and like mechanical actions. But bear with me, it's going to be fun also to do it here. Okay, so I'm just going to add one instruction to open or close this gripper. That instruction is actually pretty easy, just like this one. So we wait for 2 seconds or 1 second or whatever. Make sure that the robot is exactly sitting there. And then we just send the command to close the gripper. Okay, I'm going to right click here and insert another action. And you can see again, it automatically populates the pick process here. And I'm going to set DO. Set DO means that I'm going to set a digital output to a number. And digital output is basically just like an electric switch. It's either going to be on or off. It's either going to be 1 or 0. There's only two options, 0, 1. These high, low, and other stuff are basically the same. We're just going to use 1 and 0. And we need to make sure that we have selected the correct signal. To be honest, in this robot, we have too many of those signals. And if you want to see like how many signals do we have, I can actually show you how many signals do we have on this robot. This many signals. So if you open your this part of your Robot Studio file, you will see like there are lots of them here. But there are a couple of them that have like meaningful names, like spindle power, spindle tool, tool gripper open, tool gripper close, and these two dangerous ones, tool plate lock and unlock, that hopefully no one is going to mistakenly take as these two. So the one that we are going to play with is the one that's called DO, which means digital output, tool gripper open. And you are seeing another one that says DO tool gripper close. Do not get confused with this one. We're just going to play with this. And in the lab, I will explain why do we have two of them. Okay, don't get confused. Just here, open this drop-down menu and select DO tool gripper open. Okay, we are going to use this one. You can define them by yourself, but that's not the case with this robot and this file. Basically, on this specific robot, we never change these things. We just repurpose them for the practice that we want to do. So here, we have this DO tool gripper open, and we say, okay, let's open this gripper or make sure that it is open. And I would say create. I need to get back to this menu to see it. Okay, so this command here should open the gripper at the beginning of our work. And I actually want to put it all the way at the beginning to make sure that our gripper is going to be open when you are starting the process. And this is really important. Whenever you're doing something with these robots, you should never trust the person who used the robot before you, and you should never trust yourself from 5 minutes ago. So whenever you are starting a process with the robot, make sure that you are resetting everything into its original position. Never assume that the previous person, including yourself or me, has done this job for you. So whenever we are doing the job, we want to make sure that our gripper is open. Just imagine that you want to grab something and you go all the way to the object, and then you realize that, oh, my gripper is closed. So it cannot get closer more than this. So make sure that your gripper is open at the beginning, then start the workflow. So when you get to the place that you want to grab the object, it has this action available. So I put one gripper open at the beginning of the workflow just to clean up everything, make sure that our gripper is open. And then once after that 1 second wait, I want to make sure that I'm closing the gripper. So I come back here, I again insert an action. It's again that set DO. And this time, the same thing. And this time, I set this gripper open to 0, which means that it is not open anymore. So I hit create, and it does the job. Okay, seems legit, seems fine, but it's not done. Whenever you're using a mechanical system, it takes a while, like it takes a second or a fraction of a second for this mechanical part to close itself, okay? It means that if you move immediately after this set DO, the robot tries to grab the object, like imagine that these fingers are moving slowly, but before the fingers are getting completely closed, the robot moves back. So we need to add another wait command right here after this set DO. And it's going to be pretty similar to this wait command that we had previously. So I just Control-C and Control-V here. So I'm not going to go through the whole workflow. And then sandwich this set DO gripper open between two wait commands, which means that the robot gets here, wait for a fraction of a second or 1 second to make sure everything is settling down, then closes the gripper and waits 1 second until the whole gripper gets closed, and then starts moving back. So this is really important. This sandwich here, like wait, action, wait, is really important for your workflow. And the same logic applies to here. So basically, instead of just making all these actions, I'm just going to Control-C and Control-V here. Oh, does it work? No, it doesn't work. Okay. I need to grab and drop this one here. I also copy paste this one, which is a gripper open, and put it here. So in the pick place, we open the gripper, we move there, we wait, close the gripper, we come back. In the placing process, we get to that position, we wait for a second, then we open the gripper and we move back. So it seems that in this scenario, we have the whole workflow done. Let's see if it's working. So let's move along this path. The robot goes there, save, pick place, waits for 1 second, it closes the gripper, it comes back, and something fishy happens on your computers if you do this. Your gripper is not going to get closed. Am I right? Does anybody have any gripper getting open?
Yes,
not.
my gripper are not able to getting close.
Okay, does it close? Like, do you see that? It should
well,
not. If it closes, I'm getting surprised because you need to.
No, it's not closed. It's not closed. But it's even no. It's
okay.
even it even didn't get close to the box. Yeah, it's just.
Okay. But it gets there. Wait for a second, but the fingers are not actually opening and closing. Am I right?
Yes.
Okay. Yes. But the rest is being done. Like your robot moves to that position and wait for a second, and then wait for another second, and then moves back. Am I correct?
Yes.
Okay, great. So the reason that my robot actually does this mechanical action is because I defined this workflow, which is the topic for the next couple of minutes. So how we can make a tool that actually does this job. By this job, I mean like closing and opening its fingers. So here's the another topic that we want to cover today. It's called mechanisms. So if you remember, we previously defined a tool. And that tool had this orientation. It has its TCP, it had weight, the center of gravity, and other stuff. But it was a solid object. It wasn't doing anything special. It was just a solid block of material that we would put it on the tip of the robot, the flange of the robot. But this tool that we have here has a mechanical action. It has two fingers, and it's in its open status, it looks like this, and its closed status, it looks like this. Like these two fingers are actually get close to each other, and it closes. So somehow we need to define a tool that has this capacity to do this job. But how can we do this? So in order to do this, I need to bring up the file that we had recently. So this is the file that we brought. Actually, it's uploaded on your Canvas, and we used it the other day in order to model the gripper. So I'm just going to clean up everything so we can see it. Okay, here's the tool. So if you remember, this was the file that we used the other day in order to make our tool. And if you remember, we just skipped this part of the file, but we kept this, and this. Okay. So what we did the other time was actually we exported all these pieces together and brought them to Robot Studio and used them as a static tool. But right now, we want to have a tool that's capable of doing some action like, I don't know, like this. And it's actually closing its finger. So it has two states like this one and this one. So how can we do this? How can we have a tool that has this mechanical action? We need to introduce this tool as a mechanism. And mechanism means that it's an object that has a special poses that can switch between them. So in this case, we have a gripper that can do a closed pose or position and an open position or pose. So we need to somehow define this one in Robot Studio in that way. In order to do so, we need to separately bring pieces of this tool to Robot Studio. So basically, I want to bring this part as one piece to Robot Studio. Then I want to bring this piece and this piece. So basically, this tool that we previously imported as one object is now going to be 3 pieces. And then we are going to mash them together and make a tool that can actually close and open and help us with these simulations. Okay, so let's do this. If you remember from the other time, we were supposed to export everything as a SAT file. Actually, SAT or STL. I think STL is the one that's working better for us. So we should select export selected. And let me see. Yep, let's go to session 5, make sure that I have the correct files. Okay, so I'm going to use STL format, which is here. And you see that I only selected these 2 pieces, like only these 2 pieces. 0 and 1. And I'm going to call this one gripper base. And I'll export it. Yeah, I'm fine with all those things. Okay, this is the first part. And it's a heavy file, I know. Then I'm going to export this one. And again, I'm going to call it gripper. And then let's assume that this is the left finger. Left finger. And this is also going to be a heavy one. And then I'm exporting this one. Gripper, right finger. Okay, good. So I exported these 3 pieces separately to make sure that I can actually connect them together and let them work. So these 2 pieces together, this piece and this piece. So 1, 2, 3. Good. Now it's time to import them into Robot Studio. So let's see if I have that one. Yep, here. And I have these 3 pieces. Let me see if this works. Yes. So if I grab these 3 and just drop them here into my file, they are going to show up in this corner at the center of coordination system, slightly higher than the ground. And as you can see, they are showing up in 3 different pieces and they are separated from each other. And now we can convert this whole thing into a mechanism. There is one catch here. They are 45-degree rotated. And this is going to make everything a little bit hard for us. So I'm going to select all of them. Remember, select all 3 of them, right click, and let's rotate them all together. And since they are located at the center of coordination system, it doesn't matter which coordination system we use. I'm using world. And I want to rotate them like this. And as you can see, basically, I want to rotate them around the blue line, which is the Z axis. So I'm using this command here. So I'm using Z, and I exactly say rotate them for 45 degrees. Now they look like legibly in the correct place. And I will explain why did I do this later on, because it's really important to do this. Okay, so we have these 3 pieces. Now we want to make a mechanism out of these 3. For that one, we go to modeling and we select create a mechanism. And you can see that it is conveniently sit next to create tool. So we're not going to lose it. Okay, so let's hit this one. And now it shows up this menu here, which is really important to follow closely. So if you feel something is wrong here, just immediately ask question, because it's a complex process and I want to make sure nobody is missing any part of this one. So first of all, make sure that you have a good name for this one. So I'm going to call it Reaper Mechanical. Okay. And this is the name that it's going to be called later on. And then I want to make sure that it's defined as a tool. Okay. So it's a tool and it's called Gripper Mechanical. Now there are options here that we should closely select. So the first question is, what are the parts of this tool that we have? So as you remember, we had 3 parts, this base part, left finger, right finger, and these 3 parts, these 3 links should be introduced here. So let's go. So I'm going to first name this one as base, and I will select the gripper base from the components. Okay, it's really important. Make sure that you put a good name on it. Make sure that you select the base part, which is this one. Make sure that you say this is the base link, so it means that everything else is connected to this one. Then you can add the component and hit apply. As soon as you hit apply, you will see that this part is getting updated. So it says that the base link of this mechanism is this part, and it's the base part of it. Okay, now I want to go to left finger. And I know that here I have the left finger, and I can say add this part, and I can say apply. So you see that this part just get added. And then I want to have the right finger. And again, I'm using the geometry of the right finger, and I will add it and apply. So once we have all these 3, base, left finger, and the right finger, we can stop here. So we know all the parts of this tool. Okay, now we will have joints. Basically, in this part, we should say which part of the system is actually moving and how much it moves. So when I say joint, we usually think about like joints that are rotating. Like if this is one and this is the other one, it seems that joint means something that rotates. But in this case, we have another type of joint that instead of rotation actually slides. So basically, if you wanted to define this gripper, we want to somehow say that, okay, this part of this tool goes this way and this way. and this finger at the very same time goes left and right. So it is called a prismatic motion. And we can say that, okay, the left finger of this tool slides back and forth, and I know that the amount that it moves is only 20 millimeters. So if it starts from 0, 0, it can move for 20 millimeters. Okay? And we need to say like what is the limit on each side. So I would say it's between 0 and 20. And I can actually see, oh, actually I selected the wrong one. Okay, but it's working. So this is the motion. Okay. So this is what we want to see. So at the first position is 0. And then when we jog it, you see that it gets closing. It closes, and then that's the 20 value. You should remember, this is the first position, this is the second, and when you slide these two should actually show the correct position. So I hit apply, so this finger is working. So apparently we are looking from the other side, so the left and right are actually flipped. So again, now it's asking about the right finger. And you make sure that you select the base finger correctly. So you should make sure that the base and parent is like this one, base link. And we have already defined the left link. So right now we are thinking about the right link, the right finger. It's prismatic. And this time, let's make sure that we are selecting the correct value. It should move between -20 and 0. And let's see if it's moving. Okay, second value is -20. Okay, so I made a mistake. It should be -20, like actually 20. And 0, this one should be 20. Okay. No, why am I doing it in the wrong way? Now it's correct. So it goes from 0 to 20 and it closes. Make sure that when you're changing, moving from the first position value in here to the second value, it actually goes to the correct direction. Yep. Am I making a mistake about this part? No. Good, apply. Good. And we have only these two fingers. So we have the joints. Now we need to define the tool data, which is something that we used to do previously. Basically, we just want to define where is the TCP of this tool. So basically, I'm going to say that mechanical TCP, tool data, and it belongs to the base link. And if you remember from the previous time, it was 295 millimeters above the ground, above the 0 value. Oh, sorry. And we just need to make sure that we have some meaningful weight on this tool because it's a mechanical piece. We're going to say it's 5 kilograms. And we assume that the center of gravity of this tool is somewhere here. And I can just like estimate that it's 150 millimeters above the ground. So this is basically the same thing that we've done before with these tools. So when we do this, you see that all these check marks are green and we are fine. So we can compile this mechanism. And this is the mechanical system that we want to make. I can now add positions to this one. So I can define a position that's called, for example, home, or I can call it close, or actually open. And hit apply. And then I can slide these two and call this one close. Okay, now we have a tool that has two positions. One of them is open, one of them is closed, and it can easily get triggered by some signal like that, a digital output, digital input. So I'm just going to close this part. And now I want to install this tool on my robot. Okay, so the only thing I need to do is to just, where was the name of the, yeah, this is the tool that I just made. And I can actually install it on the robot by dragging and dropping it here. But I'm not going to do that because if you remember from the previous part, the previous session, this tool should be rotated again. For 45
sorry,
degrees.
excuse me. Sorry, I didn't follow the make drawing parts, because when I finish the instruction, the apply button is still gray. So
Can you share your
like,
screen so we can have a look and see what's going on?
well, it's okay, but I have to, because
Is there anyone else who has problem with this workflow? Because we are going to continue the class based on the functionality of this tool. So we need to make sure that everybody can make this tool. Join site. So first thing here is the fact that you did not rotate everything. So that might be a little bit challenging.
yes.
So maybe you should rotate them right now. Like select these three pieces, like the right,
Okay.
left, and then go to home. Actually, right click on them. No, you don't go home. Right click on those three objects, like here. No, here. Oh, let me give it a second.
Orientation.
No, you need to click. Actually, you can, yes, here. Position. No, position here.
Okay.
And rotate. Now make sure you're selecting Z, because we want to
Z?
rotate them around Z axis. No, Z in here.
Okay.
Yeah. And then we want to rotate them for 45 degrees. You need to enter the number here. Oh, there's some,
Right.
on this side. Oh, it seems that my when I draw something, it doesn't. Yeah.
Sorry.
No, make that 0. Yes, here. Yes. Apply.
And apply.
I think you just
Yes.
rotated 3 of them. One of them didn't rotate.
Oh,
Somehow.
really?
I think that's the left part.
And station rotate.
Yeah. 45. Apply. Somehow one of them rotates for some extra amount. So let's go here. You see this part? Like on the left menu, yeah. Like, can you click on that small triangle next to it? Yeah, there's a small triangle next to it. Yeah. So you see, like the left and right are also connected to each other. Is somehow, maybe you should repeat this process. Yeah, maybe if you delete that part, it's going to help. Yes, now click on the left one, which has not rotated. Yeah.
This one.
Now rotated that one. Yeah, apply. Yeah,
Oh.
good. So you have the 3 parts. Okay. I suggest that you should actually delete all the links that you already made. Delete those 3 parts. Yep. Remove link. Yep. Remove left. Yep. And then remove right. Okay. Now let's go ahead and repeat this process together. So double click on, okay. Now select the base part. So at the beginning, we always select base. So let's call it base. Awesome. And also select the base part. Like in the drop-down menu, select component. Make sure that you're selecting the base part.
This one. Yeah.
So you called it, what was the name that you used for importing it? Gripper 1, 2. Yes, that's it. I think that's the case. Okay. Now add this one. Okay. Now you need to hit apply. Yes.
Yes.
Now you need to add left and right fingers.
This one.
Yeah?
Yeah. Where is
So,
left?
Maybe it's left. I'm not sure from which direction we are looking. Yeah, left. And add it. Now you need to hit that triangle. Yeah, everything is right. Like, no. Oh, yeah, correct. Apply. Good. And then you need to do the same thing with the right one. Okay, hit apply and then, okay, so it's going to get canceled to close this one. So you have all the 3 parts and it seems everything is fine. So the links are correct. Now you need to define the 3 joints. Actually, the 2 joints. So these are not rotational joint, as I mentioned. So they are prismatic joints, so you can move them left and right. So you should make sure that you're selecting joint type as prismatic right below the joint name. Now you don't need to select anything. You just need to say that it's a prismatic joint.
Oh, okay.
Yes, exactly. Now let's put a name on it. Let's call it left joint. And yep, great. Joint, there's a T at the end.
Oh, sorry.
Yes, good. So you have selected the left part, everything is fine, prismatic. Yeah, now you need to set how much it moves. So the parts that you should make sure that are correct are first position and second position. So for the first position, we usually leave it at 0, 0, no problem. We don't play with that one, okay? But for the second position, which is here, you should put 20 on that one. I'm not sure if it's good. I think it's going to be minus 20, but for 20, let's go for 20 for now. Don't change anything else because these two fingers are only moving in X direction. So they are only going to move in the X direction, so no problem. And don't touch that part because it automatically populates the direction. And now you need to make sure that these 20 and 0 are correct. So go down there and set the minimum limit into 0 and the maximum to 20. And then try to, yes, 20. And then try to play with that slider, jog axis. You see there's a slider up there? Like, yep, there.
Yeah.
So
Okay.
try to, no, this slider, this part.
Okay.
Yes. Now move from 0 to 20 and see in which direction it moves. Okay, it closes. When you get 20, it gets closes. Okay, which means that this is correct. So in the first position, we want the gripper to be completely open, and the second position we want to get close. And this mechanical system only closes for 40 centimeters in all directions, which means that 20 centimeters in this one, 20 centimeters in that one, and overall 40 centimeters, and that's it. Okay, so we are fine with the first joint. Good. Apply. Yeah. And then we need to repeat the same thing for the other finger. So right now we need to play with the right finger or right joint. Yes, you should make sure the parent link is also base, not the left finger. So if you mistakenly select the left finger as the base for the right finger, it means that these two fingers are going to be connected to each other. So instead of doing this motion and closing, when the left one moves, the right one also moves with it, like together. So yeah, you're right. Okay, the first position is 0. The second position is this time, I think, 20, minus 20. Because basically this one should close. Okay, set the limits, maximum and minimum. So I think the minimum is minus 20, and that one is 0. And then let's try, okay, maybe we should flip these numbers. Yeah, that should be 20. Okay, and yep, 0. No, that one is 0 and the other one is 20.
Oh, you mean
0,
this one
minimum
0?
Yes, and the other one is 20. Okay, now try to play with it. Okay. I think the axis direction should be minus 20. Can you change this axis direction into minus 20?
Axis.
Yeah.
Yeah.
Yeah, basically the direction should be changed. Okay, now try to play with it.
Okay, yeah.
Yeah, okay, good. So hopefully it plays. Okay, apply. And then okay, now you have the two joints. Close this, cancel this one, so it's done. Now the only thing that remains is to define the tool data, which basically says that where is the TCP of the tool. So double click on tool data. Okay, so here, this is the classic part that we have done before. We just want to say that the TCP of this tool is somewhere here. And sorry for the delay between my drawings and whatever happens on your screen. So I put a good name on this one. So call it like Gripper Tool Center or something like that. Yeah, spacebar would be like leave underscore between tool data or something like that so we can see it. Like between
So it's
gripper and tool, put an underscore.
Oh, sorry.
Yeah. Because right now it's really hard to read it.
Mhm.
Okay, base is fine. And the position is like, we know that there's the distance between the base and this TCP is 295 millimeters in Z direction.
Mhm.
So,
So here,
so that one is 0. No, that's X. This is Y and this is Z. The
oh,
last
so
one
this
is
is
Z.
Y. So this is Z.
Yes,
great.
exactly. 295 in Z. Awesome. And so there is no rotation or anything. And then the weight should be set, like 5 kilogram is something that we want to go for.
Mhm.
And the center of gravity for this tool is somewhere here at the middle. So maybe we should say that this is like 150 millimeters away from the base.
100. Mm.
Yeah, great. So hit OK.
So okay.
Yeah.
Okay.
So we have the tool right now.
Mhm.
I think something went wrong here because I don't see it there. Okay, so can you double click on that gripper tool center? I think something went wrong there. No, it's there. Yeah, good. Now everything is done. You see that all those check marks are, just cancel this one. We see that all these check marks are green, which means that everything is fine. Now we can compile this mechanism. So hit on compile, and then we can compile it here. Oh, no, it's actually right here. Okay, my pen doesn't write anything anymore. So it's on the right below the parts that you just wrote. Yeah. Yeah.
Oh, this.
Yes, exactly.
Yeah.
So when you hit this one, it's actually using all the data that you made in order to make this mechanism functional and practical. Now we need to say which conditions this mechanical system has. So you go to poses and hit add.
Oh, here.
Yep.
Okay.
And then let's say that this one is called open.
Okay.
And it is already open, so you can just say it apply.
Mm-hmm.
And then we want to have another one which is close. So we play with those sliders until this gripper gets into closed position. Yeah. Now we hit apply. Like make sure that both of them are in closed position. Like both of them should be on 20. Yep. Now you can say apply. Good. So we have two poses. One is completely open fingers and one which is completely closed fingers. So right now, if you look here in your tool data on the left, what was the name of the mechanism that you made? Okay, it's here.
Okay.
So this one is gripper LM or whatever. You can actually change the name if you want. But this one has a wrench sign next to it, which means that it's a tool. And it can be used to be installed on the robot. So if you just rotate, first we need to rotate it and then put it on the robot. So you can actually close this part, close this menu, so it's not going to bother you. And my suggestion is to rotate this whole tool for 45 degrees. So position. Yep.
Position,
rotate.
rotate.
Yeah, it's going to open the menu for you. Okay, fly. Okay, now we can install it on the robot. Just grab it and drop it on the robot. Yeah, attach it to the robot. But before that, it's a good idea to detach the previous tool from the robot.
Oh, right. So
cancel everything. Detach the other tool. I think it's gripper test. No, not this one. So your current tool, yes, that's it. That might be the tool.
And
there's a delay between your computer and my screen, so I'm not sure if I'm seeing everything correctly. But if you zoom back and look at your robot, yep. And whenever you're lost in this procedure, just double click on the name of the robot and it's going to exactly show you where it should go.
Yeah, it has been attached successfully.
Okay, now drag and drop this one on the robot. No. I think you just put it on the wrong place. Cancel. The robot is the one above
Oh.
it. Yeah.
Yeah.
Yes.
Okay.
Now you have the tool on the robot. Okay?
Mm-hmm.
Good.
Yes.
So we are in good track.
Mm.
Okay, so let me just stop sharing and share my
Okay,
own
thank you.
screen.
Yes.
Okay.
Okay. Okay,
Is
excellent.
this my computer? Yes. Good. So let me just put this.
Thank you.
Here.
That was very helpful.
Okay, great. So I think it's a good idea when I'm showing something on my screen with my pace. After that, somebody should actually replicate the process on its own screen, and I just help the process so everyone can understand what's going on. Okay, and I also increase the size of everything on my screen. So if you're following everything on your iPad with a small screen, it's going to be more helpful. Okay, so I think I haven't installed this tool on my robot. So let me just detach this tool, make sure it's not on the robot. And let's hide it so it's not going to make any mess with my other files. So as I mentioned, first we need to rotate this tool, make sure that it's getting back to that 45-degree rotation. And again, I'm selecting Z because Z is the vertical axis here, and you can see that the blue line is the vertical axis, that's Z. And I hit apply. This tool will rotate 45 degrees, but to be honest, I want to rotate it minus 45. Does anybody remember how could we say which direction was positive and which direction was negative rotation? It was somehow related to right hand and thumb.
Like right hand rule.
Yes, so we had this rotation right hand roll. But what was the rotation for right hand roll for rotation? If you have your thumb in the positive direction of an axis, then when you're closing your fingers, it is going to show you the positive direction of rotation. So right now, if I say like, let's rotate this piece for 45 degrees, it means that like based on the right hand roll, if I put my thumb here, it means that it's going to rotate. My pen is not writing anymore on this screen. Okay, it means that it's going to rotate counterclockwise when we are looking from this direction. And I want to rotate it the other way around. So this is it. Now I can connect this tool into my robot. So there are easy ways and hard ways of doing this. So the harder way, what's this one? To make sure it's not messing with anything. The hard way is to go here, attach it into 6640 robot and here. The easy way is to actually just grab it and drop it on the robot and say, yes, it's going to show up there. And let's see this robot is working or not. It's actually working. The only problem is that I moved my tool in the wrong direction. So yours is going to work perfectly fine. Mine is slightly rotated. Okay, so what was the name of the TCP for my tool? Does anybody remember? Yeah, it's correct. Okay, so this is functional. It's working. Everything is fine. And it follows those targets. The only thing I should do is to make sure that I also change my tool on all of these motion actions. So I select all these motion actions, modify instruction, and I make sure that I select my newly defined tool. And then everything is going to be fine. Remember, when you are setting a tool, setting a motion action, it remembers the tool that you have selected previously and uses that one. But once you change your tool, you need to redefine this workflow. This is really important and critical. Make sure that you are following this. Okay, so we have everything. We have a mechanical system that should follow this workflow. And I'm going to move along this path and see if it's going to work. And let's see if these fingers are going to get closed and open. Wait for it, and nothing happens. So what happened here is actually a miscommunication between the tool that we have or basically the lack of communication between the tool that we have and the robot. So we define this tool as a mechanism. And we are saying that this tool can do something. And we also set a DO to do the job, but we didn't connect this tool with this digital output. Somehow we need to connect these two together to make sure that the mechanical system can listen to that signal and do the job. So I go to the simulation page, simulation tab. I hit this small rectangle and like, I don't know, arrow, whatever it is here. And I hit event manager. So I have a bunch of things here. So I'm going to delete these. Oh, I actually need to delete them one by one. Delete. These are the files that I had previously have here. Delete this one and the last one. Okay. Then this one should be deleted. Okay. So it's a clean space like the one that you had previously. Now I want to make sure that whenever I'm changing that DO, that gripper opens and closes. Okay. So I'm going to hit add. And I'm going to say that I'm going to make an event that's connected to that digital output. So I say that when the system is on and you have an IO, for example, IO means input and output, which covers both digital output and digital inputs and analog outputs and analog inputs. So whenever something happens with one of my signals, which is this one that I'm really interested in, let me find it. Yeah, here. When this DO tool gripper open is set to 1, I want my gripper to get open. So DO tool gripper open, signal is true. I want this mechanism to move to a specific pose. So this is the option that we should select, move mechanism to a pose. And then it's going to ask us which mechanism we want to play with. I would say mechanical gripper that I just made. And I want to go to the open position. And I hit finish. We should make another one exactly the same workflow. So it's going to be on activation, IO signal. And then I'm going to select that. Oh, I need to expand this. DO fixture open. Oh, no. My bad. Tool gripper open, set to 0. The other time it was set to 1. I want to move a mechanism to a pose. And that mechanism is gripper mechanical. And I want to set it to close and finish. Now, if you look here, you see that IO, which robot it wants to work with, tool gripper open. When it is set to 1, we want to move that mechanism to one of the special poses that it wants, and it's called open. When this is set to 0, we want to move it into close position. Okay, this way, hopefully it's going to work. We are going to see that robot closing and opening the trigger. So does everyone have the same menu as the one I have here, the same chart? If anything is different, something is wrong. Then make sure that it's exactly looking like the one I have here. You can go ahead. Good. So everything is fine here. Let's get back here. And now let's move along this path and see if it's working. You see that? The gripper opened at the beginning. It goes down. Let's get there. It closes. It moves back. And it finishes the job. It seems pretty legit. It's actually exactly what we were looking for. Let's see if it's doing the opposite direction when it is going to the place process. Yeah, it does the job. It goes there and opens the fingers and everything seems cool. And that's basically what we wanted to do. We just wanted to have these DOs and make sure that everything is working. It seems that we are done. Like it's doing the job. I'm not going to explain that physical grabbing of the object because that's another complete session. I'm not sure if it's going to help that much unless we do something in the lab. So far, we defined this whole workflow in a nice way. It has a peak process. It has the place process. And it seems done. Like, yeah, everything is fine. But there's one catch here. This workflow is not done. Right now, whatever we have here is just in this Robot Studio visual environment. Visual Studio needs to convert whatever we have made here into a language that the robot actually understands, and then convert it into that language, give us a file, and we need to load that file into the real robot. So next time when we go to the lab and we want to work with the robot, we just cannot run this Robot Studio and say, hey, robot, please replay it. We need to convert this whole workflow into something that the robot understands, grab it on a USB stick or something, stick it to the robot, load it, and then run it. The language that this robot understands is called Rapid. And there's a tab for it here. So if you go to this tab, Rapid, you will see that everything changes. And it has this option here that shows some programming language here, which is the one that the robot understands. And as you can see, these are the code that I wrote the other day, but it's not exactly what we were doing today. In order to get whatever we have done and bring it here into this programming language, there's a process called synchronization. And that synchronization is here. So basically, when we hit synchronization from station to rapid code, whatever we have done here, like these parts, are going to be translated into rapid code, and then it will be readable on the rapid tab. So we are going to do that part. So your file might be slightly different, like yours doesn't have this, doesn't have this one, and doesn't have this one. Okay, so I want to make sure that our code is going to be properly converted into a rapid code. And to do so, we need to do some extra actions. Okay, I'm going to just compress these two procedures and make sure everything is clean. So in order to do this job, we need to copy these two commands that we want to run. So I'm going to select one, hold Control, and then select the other one. And I'm going to drag and drop them into this main procedure. And you may ask yourself, like, what is this main thing? Like, it didn't make it. How does it show up there? The point is, main is the default procedure that the robot looks at whenever it wants to run. So when you generate a rapid code and you hit run, the robot only looks at the main procedure and nothing else. If you have copied your codes into this main procedure, they are going to run. If not, they're just going to be there without any special use. So this is the part. We have this whole workflow. We have this main procedure with this pick and place procedures. And we need to convert these codes into rapid code. So first, I make sure that I'm selecting this part. As soon as I select this main or pick or process, you will see that this synchronized bottom is getting colorful. Right now, it's gray because it doesn't know which robot we want to work with. As soon as we hit here, it's going to get blue, which means that it knows which robot we want to synchronize with. So if you just hit synchronize, it's going to get everything from station, which is this 3D environment, and convert it into rapid code, which is the default. But sometimes we want to do the other side. Like we have something in rapid code, we want to bring it into the station. Think about this station and the rapid code as a Rhino and Grasshopper. If you have experience with Rhino and Grasshopper, you know that if something is in Rhino, you need to introduce it to Grasshopper to work with it, or if there's something in Grasshopper, you need to bake it. This is also the same logic. So I synchronize everything I have here into my rapid code. And then I need to check whatever I have changed. So you remember that I changed these like place process, and I also changed main, and I also changed my mechanical tool. And you can see that there are lots of options here. For now, don't change anything here. It's fine. We just need to hit create, hit OK. And as soon as we do this, everything is going to be moved into rapid code. So here, I can actually delete this part. You don't have it. So as soon as I do this, you will see that probably in your computer, it looks like this. It says procedure main, peak process, place process, and probably nothing else. And if you go here into this module, you will see you have a peak process and you have a place process. And if you look carefully at these things, you see that that tool gripper open is actually here. That move J is here, move else, wait time, set DO for the gripper close. Everything is actually here with really understandable language. So basically, here we have a description of whatever we define in our station. So look here. In our peak process, we have set DO, move J, move L, lop, lop, all the way to the end. And in our rapid code, it is exactly the same. So rapid code is the scripting language for this robotic arm. And the rapid tab in Robot Studio is the environment in which we can define our codes in rapid language. And if you start looking around in this code, you see that, oh, that starting point that I had, it's actually here with all the X, Y, Z's that we defined for it. And technically, we can update these numbers and set them into more nicer numbers. That speed value that we used to have here, it's actually here. The Z0 is here. These crazy 1000 speeds are here. And it seems that everything that we define in the station visually can also be defined here using a programming language. And here's the fun fact. You can actually edit everything here. For example, I can convert this one into fine. I can convert this one to 50. I can change this number into, I don't know, maybe like 5 or whatever. And I can play with everything here and it's going to be functional. And seems pretty cool, pretty nice. And we can do whatever we want. And I think it's really powerful option for Robot Studio to have this visual environment and at the very same time that crazy coding environment that we can do a lot of stuff with. So once you're done with this part and once you synchronize everything, for the sake of just clarity, I'm going to synchronize again. Okay, now you can actually run a simulation. So I'm just going to close this one. I can go to simulation and hit play. Simulation is basically running that rapid code, not your station. So when I hit play, it's going to get into your rapid code and see what's going on over there and runs it. It goes there, it closes the gripper, moves up. And if you remember, I made a mistake about the speed of the robot here. So it moves for like 1000, it leaves the object there, and it comes back to original position. And now if you look carefully, you will see how that move L and move J are different. So this pass that's moving right now is a move J. So the robot just like, moves the easiest way it can. But at the beginning, it uses move L, which is completely linear. This is move L. And you can actually continue this simulation for thousands of times. But you can at the very same time record this to a viewer. So I actually hit that small triangle below the play button. And when you do this, it's going to save everything as an exe file, which is an executable file. And then you can share it with whatever you want, whoever you want. So in many cases, when we are doing the homeworks or lab assignments, I'm asking you to share that exe file. So once we are done, we can hit stop, and it's going to ask us, like, where do you want to save that one? And I would say I want to have it in my session 5 peak process. Done. And it's going to save that file for me. Later on, I can just go over there, run that file with no problem. So it's actually here. I can double click on it and it's going to open it. And if I hit play, it's going to show everything for me. If you are bored, you can actually move it faster. But it's an exe file. You can set the lighting and other stuff. You can actually set the viewports or whatever you want. So that's it for today. Hopefully for Thursday, we are going to be in the lab. If you have not ever been in the lab previously, you need to actually get out of the building, and from the back of the kindergarten, you need to go to the ramp and then downstairs and knock on the door, or I think you can right now swap your card. And then I will meet you outside before the class. Like I will be there around 9. So I'll try to be there before you. So if you get there, have your masks on. If you have any other system of protection, personal protection, definitely bring it. Make sure that you have your hairs tied at the back. Make sure that you don't have any loose outfit, like no jewelries or anything like that. The handbook actually says everything about it. Like I think I put some file in the. I'm also going to give you the lab handouts. I'm going to upload it on Canvas as soon as possible, maybe a couple of minutes later after the class. But make sure that you're prepared for being in an industrial environment. And I'll be there earlier. If you want to show up at 9:20, that's fine, but don't be late because it's a little bit hard to find that room. And I'm looking forward to see you all on that day.